Assalamu alaikum. Welcome back to School of Physics. In today's lecture, you have already seen that in the previous lectures were discussing about the second law of motion, first law of motion, and the things like that which were dealt by Newton, which were called as the Newton's laws of physics, which were called as the Newton's laws of motion. And till now we discussed two laws, first law of Newton and the second law of Newton, second law of motion we can say. And today here in this lecture we will deal with few problems on second law of motion, like we will deal on second law of motion problem set. Okay, few problems. These will be simple problems, very much low standard problems, just to give you an intuition about how the second law is applied onto the problems. Okay, so let's take an example. It's a problem actually. So let's suppose that we have a bullet fired on a wooden block. Okay, here is a wooden block, and its mass is the mass of the bullet. Here it is. This is the bullet fired onto it, and its velocity is 90 meters per second. Okay, and with the mass of the bullet is suppose 0.04 kg. This is the mass of the bullet, and suppose that the bullet hits onto the block here. From here it bursts into the block up to a distance of 60 centimeter, or we can say 0.6 meters equivalent. Okay, so up to this very point this bullet bursts and gets stopped here. Ultimately the initial velocity, keep that in mind, the initial velocity you have seen was 90 meters per second. Okay, now the final velocity. Now first of all, what the question says, it says that what it will be the average force applied onto this block. Average force, I'm calculating, keep that in mind, average force, because otherwise the force applied here will be the function of velocity also. Function of velocity. I am considering average so that this term will not matter here. Okay, so that is the thing which is to be kept in mind. The force which we are going to calculate is average force. So we have to calculate the force which is exerted by the bullet onto this block of wood. Now how to calculate this? We have seen that from the problem the initial velocity, and keep that in mind, the resistive force of the air, or we can say air resistance, is negligible or is zero. Okay, keep that also in mind, otherwise these all effects come into effect and they will alter the shape of the problem. Okay, so these are the things which we have to keep in mind. Now we have seen that the initial velocity of the bullet, initial velocity, say u is equal to 90 meters per second. The final velocity, upon hitting the block it gets stopped and ultimately velocity comes to a halt. Okay, so in that case velocity final, I can represent it by v, denote by v, and it is 0 meter per second because it is stopped ultimately. Fine. So how we can calculate the force applied onto the wooden block? So that is given by the second law, because we know from the second law of motion, second law, force is applied onto it will be given as equal to mass into the acceleration. And we know mass of the bullet here, because the force is applied by the bullet, by the way. Okay, so that's why we have to consider the mass of the bullet. Mass of bullet. So We know the mass of bullet is given here to be, where is it given? Here. This is the mass of the bullet. Okay. Now we have to calculate the acceleration, and for acceleration we will use, we know the formula from the equations of the motion. I will write it down here. Equations of motion, there are 3 of them. Equations of motion, keep them in mind, these are very much useful. Final velocity is equal to the initial velocity plus acceleration times the time. Okay. Second equation, v square minus u square is equal to 2as, where s is the distance traveled. Okay, and a is acceleration as usual. And the third equation is distance is equal to ut plus half of at squared. Okay, these are the 3 equations, and we know we have to calculate the acceleration right now. These are all the acceleration terms here. So which formula to apply here? We have given velocity, final velocity, that's okay. U is given, acceleration to calculate, but t is not given. For how much time it applies onto it, how much time is taken by this is not given, so we can't apply first. Similarly, in the third case, t is not given, so what remains? Second one, because the distance traveled upon pressing into the block, that's also given, that is s here, is 60 centimeter or 0.6 meters. Okay, so we can apply the second equation, use this equation, that is v square is minus u square is equal to 2as. Fine. So to calculate what? To calculate acceleration, use this. Fine. So we can use v square is our final velocity, this was the initial. Okay, final velocity, which is upon stopping the body, stopping the bullet, what was that? Final velocity is 0 squared minus initial velocity 90 meters per second square, that is the initial velocity is 90 meters, 9 square is equal to 2as, 2 times acceleration, we have to calculate that, and distance burst into the block upon hitting the block. How much distance is covered? So we are using this very equation here, and we'll get upon substituting the values of v, the final velocity, which is here 0 because it is stopped ultimately, that is v is equal to 0. So using v is equal to 0, initial velocity with which bullet was first moving, and that is 90 meters per second. So using this, and 2as, s is the distance which the bullet ultimately stop up to that very distance with where the bullet stops. In this case it is 60 centimeter, but since we are using the SI units, for u we are using meter per second and v meter per second, so for this distance we have also to use it and substitute it in terms of meters. So I used 0.6 meters instead of 60 centimeters. Okay, so after substituting we will get acceleration equal to something which is this calculated result, but here it is negative times this, we will get a minus term, and that indicates that the bullet has got retarded, that is the retardation, that is the acceleration in the negative direction. For example, if we take this very direction to be positive, and along this if a body gets accelerated, we say that it's a positive acceleration, but if it is retarded we get a minus sign inside the acceleration, and that very acceleration is called the retardation, even though that is also acceleration, but in the opposite sense. So in this case, because bullet was first moving but ultimately it got stopped, so we have a retardation in case of here. So from the second law of motion we have got, now we can use this, we have got the bullet acceleration now, this very thing, and mass of the bullet is already given. So after substituting this, we will get ultimately the force exerted by this very bullet onto this. Okay, how to calculate that? That's simple. We have F is equal to mass into acceleration. So substituting, we will get mass is 0.04 kilograms, and acceleration we have, in case of here it is retardation. I will only use the positive values because force here we calculate the positive forces only, positive. Okay, that indicates at the end of the day, if we know, we will get the force sign with a negative here. Force will be negative. That indicates that it's a stopping force, it's a resistive force. Okay, that is the only meaning of this minus 50 meter per second square. This is the acceleration which we have got here. Okay, and ultimately we get force like this, 270 something, 270 newtons. This is the calculation of force from second law of motion. You have seen the problem like this. You can solve it. It's very, very simple. So ultimately there is a point to be which is what does this negative sign indicate? It just indicates that there is a retardation, there is a resistive force inside this wooden block, and you have to keep in mind that we are calculating the average force. Otherwise, because the frictional force which is caused by this block, friction is a function of velocity and also a function of normal force, whatever normal force. Whatever the case may be, it's dependent upon these two conditions in that very specific problem. Okay, but here we are calculating the average force which we have calculated, so there is no need to state these kind of resistances or other stuff like that. Okay, so this was one problem on the second law of Newton's second law of motion. Now another